In my last video, I discussed the resilient modulus of soil or aggregate, this kind of material, and I'm revising that again here. I did not delete it. So in that test, what we take, we prepare a sample, we compact it in 3 layers, put it inside a chamber, apply confining pressure and cyclic pressure, and we apply 100 cycle Eversign load, and in the last 5 cycles we take the average stress and average strain, the recoverable average strain, and the ratio is resilient modulus. Okay, resilient modulus. Now this test is very expensive in terms of the equipment because it's very sensitive equipment. We measure the strain in soil, so it's very sensitive, and also applying confining pressure is not so easy. It needs so sophisticated equipment. The cost of this device is typically more than about, like, I will say more than $100,000. So it's expensive. So what do we do? Uh, we do some other test. uh, there are several others, but our main target is to find resilient modulus, but we do other test and correlate with resilient modulus. So other test, one test is California bearing ratio. California bearing ratio, CBR. This test, this is a, now there are some other tests. One is California bearing ratio. In my next video I will discuss another one which is called DCP, dynamic cone penetrometer test. In next video I'll say another one just by soil classification, or like soil gradation. Using soil gradation and Atterback limit, we can find MR also. So there are different ways we can find MR. Again, why we are doing this test? Ultimate target, we need this, but it is expensive. We use some shortcut, some easy test. So this is one of the easiest tests, California bearing ratio. What is that? We can do this test in two ways. One in laboratory, other one in real field, real pavement. The concept is same in both cases. If we do it in the laboratory, inside a mold, we compact a sample. If we go to real field, say this is our real material, yes, what we do, we bring a 1.95 inch piston. So it is similar to this piston, is this piston. We place it here, or here, whatever piston here, and then we apply force to penetrate here or here. How much? We penetrate either 0.1 inch or 0.2 inch. So we can penetrate 0.1 inch or 0.2 inch, whatever. Now then when we penetrate, we measure the stress. Stress is our target, yes. We measure the stress. So we measure the stress required to penetrate either 0.1 inch or 0.2 inch. So this is my measure. Yeah? This is my measuring target. We measure the stress required to penetrate 0.1 inch or 0.2 inch. Then what? Then we compare this stress with a standard, like how much stress do I need to penetrate a stone, a well-graded stone, not well-graded, a standard stone. So if I take a standard stone, if I penetrate the same thing using this piston, we know that 0.1 inch we need 1,000 psi stress. 0.2 inch we need 1500 psi stress for this stone. So if we take a stone and penetrate it 0.1 inch, we need 1000 psi. If we want to penetrate 0.2 inch, we need 1500 psi. We know this, yes? This is known, this is known. This is known, or we assume this. Then we compare this stress with this stress with this. What is the ratio? That is California bearing ratio. So hopefully you understood what we do. We take a piston 1.95 inch similar to this, and not like this. This is less than 1 inch, almost 2 inch, 1.95 inch. We penetrate our soil by 0.1 inch. If we penetrate 0.1 inch, we calculate the stress, compare it with this. If we do 0.2 inch, compare with this. Okay, and the ratio we express is in percentage, but we do not write the percentage, we just tell the value. Say I took a sample in a mold, I brought the piston and I did 0.1 inch penetration, 1 inch penetration here, and say I need 400 psi. I measured 400 psi. Then my California bearing ratio will be 400 divided by 1000 times 100. That means 40. That is my California bearing ratio of this soil is 40. Now, if I penetrate 0.2 inch and if I need say 600 psi, then we will calculate California bearing ratio 600 divided by 1500 times 100, so again 40. So this is California bearing ratio. Now the question is, what does California bearing ratio means? So in your book there is an equation. I did not memorize this equation. If I know California bearing ratio, I can find the resilient modulus in psi. To 55 CBR 0.64. So whatever California bearing ratio you obtain in a scale of 0 to 100, place it here. This equation will give you the resilient modulus in psi. So that is a shortcut, because this test is very simple. Do this test, take a piston, penetrate on the sample, measure the stress, compare it with the stone, and get a value, say 30, 40, 50, 60, 10, insert it here, you'll get MR. One MR test takes about 1 week. One CBR test takes maximum 10 minutes, 15 minutes. So very quickly we get the answer. In the next video, we will talk about another simple test to find resilient modulus. Thank you.